So a couple of days back, I was riding home on my Royal Enfield Interceptor 650. I was actually on my way back from filming the Trip Machine duffel bag review. And all of a sudden, it happened. The bike completely cut out on me. This is the first time I've had a technical problem with the Interceptor. I was doing about 50 miles an hour in fourth gear, and it was like someone flicked a switch. Suddenly the RPM dropped and I had to pull over. Thankfully, I was able to restart the bike and get 99.9% of the way home before, literally as I was rounding the corner trying to get into my garage, it happened again. I wasn't quite sure if I'd stalled it or whether it had just died, but pretty sure on that journey home I had two separate cutouts of the bike. So it's an intermittent problem that needs diagnosing, that needs figuring out, and needs a little bit of investigation. These kind of intermittent problems can be the hardest ones to solve because the bike seems perfectly fine when it's working, then all of a sudden I seem to be getting a dropout. I can't put my finger on any particular trigger for it. I can't say that I'm doing something that's causing it. I can't say that it's linked to temperature or whether or not I'm standing on one leg with my right hand touching my left ear. There's no meaningful pattern that I can apply here. So the only way to get to the bottom of it is to go through a step-by-step methodical approach to try and figure it out and get to the bottom of it. So in this video, I'm going to tell you what I did and whether or not it worked. So let's do it. So having gone through some of the really obvious things like checking the battery terminal and all that stuff and the plugs inside the headlights, I started to investigate these somewhat infamous relays on the left-hand side of the bike. You can get to them just behind this panel here, and here you see 4 relays stacked in 2 separate banks. Now on the Euro 4 model, they are as follows. You've got a relay for the mains up on the top left, the top right is the starter, then the bottom left is for your accessories, and the bottom right is for your fuel pump. So I wanted to dive into these relays mainly because they've got such a bad rap. I wanted to make sure that I just eliminated any possible problems over here before either coming to a conclusion that it's fixed or looking onwards for potentially more serious issues on the bike. So I've got 3 main questions of these relays. I want to know, are they connected properly? I want to know if they work properly, and we'll test that out. And I want to ask the question, is it worth just going ahead and replacing these anyway, just for a little bit more peace of mind? So the first question is all about the actual connection. So we want to take them off the bike, we want to do a thorough inspection and see what's going on here. And as you can see, as I started to pull these off the bike, it's a little bit of a shocker. I was actually really surprised to see the absolute mess left by the factory. I have to say this wasn't me. This is what Royal Enfield used to install these relays into the plugs on the bike. It is just lashings and lashings of this horrible, thick, white grease. This has been here for 2 years. It started to go a bit yellow. There's dirt in it. But I've got to say, this doesn't look like the best type of grease to use on an electrical connection. It's a little bit surprising. This looks like lithium-based grease. I could be wrong, but it looks like a lithium-based grease, which you'd normally expect to find on a kind of metal-on-metal mechanical joint or something like that. You'd normally expect to see more expensive silicon-based grease used on electrical components, but we don't see that here. So what we need to do is clean this off. We then need to take a closer look at the plug. We need to inspect that thoroughly, and then we can move on to testing the actual relays themselves. So first off, a can of Super 10 contact cleaner to try to blast away as much of this lard as we possibly can from inside these terminals, and it is properly packed in. I had to use a little plastic nozzle to try to scrape some of it out very gently so as not to cause any damage in here. But it was just a case of lots of blue rag, lots of spray, and eventually most of it did come off, but it took some time. So with all of this muck out of the way, I was able to kind of visually get in there and inspect the plugs. I just wanted to make sure that the connections were all in good order. No obviously loose wires, nothing that's come detached, no plugs that may have been pushed out of place or anything like that, making sure the female connectors were all in good order. And I couldn't see anything massively obvious, but I've got no doubt in my mind whatsoever that just the very act of removing all of this gunge from this plug has definitely given it a better chance of functioning properly. So with the relays over on the bench, and after a quick clean, I inspected all of the pins for any signs of damage. And I did notice actually on one of the relays that one of the pins was looking more than a little bit out of shape. As you can see here, it's slightly bent. And again, this might have been something that was causing a connection problem. Can't be 100% sure, but this definitely could have created a somewhat suboptimal connection with the actual plug. So these things are actually really important for the operation of a vehicle. Relays are essentially electronically operated switches that can switch on and off high amperage circuits using a low amperage trigger called the primary circuit. Now, all the primary circuit really does is send a current through this coil, creating an electromagnetic field. And when that coil is magnetized, it pulls down the switch, closing the secondary circuit. Now, for example, on the bike's starter system, the relay does a few important things. Firstly, that primary circuit is only activated with a live feed from the ECU. So that means it's only possible to start the bike once the ECU is happy. And when you hit the starter button on the switchgear, all you're actually doing is grounding that low amperage signal that then goes on to magnetize the internal coil inside the relay, thus closing the secondary circuit, setting off another chain of events that goes on to start the bike. Now, if you want to test a relay, all you need to do is grab some test leads, get a multimeter and a 12-volt battery. You can then use that 12-volt battery to connect the primary circuit. Now, if this is working properly, it's really obvious because you'll hear the switch actually opening and closing inside the units. So there's a little armature that's springing open and closed, and you'll be able to hear that clicking away as you connect and disconnect the battery. Now, if you don't hear this on a mechanical relay, you can pretty much bet it's dead. Now, going one step further, you can then connect the secondary circuit to a multimeter and check that it's actually flowing current. Now, as you can see here, when the primary circuit is live, we get a connection via the two outer pins. So this relay seems to be, at least in this test, working absolutely fine. Now, because these are 5-pin or changeover relays, when you close the primary circuit, rather than completely shutting off the secondary circuit, the switch is actually just swinging to this middle pin. So if there were 2 circuits connected, you could use that relay to effectively change between 2 live circuits. But we don't need to worry about that on the Interceptor because there is only 1 circuit per relay, so nothing actually ever connects to this central pin. The plug on the bike is completely empty. So I tested each of these relays on the bench as they came off the bike, and they all seemed to trigger completely fine, and they all seem to be flowing current on the secondary circuit. Now, that doesn't rule out there being an intermittent problem that I was unable to duplicate with one of these relays, but it does seem to eliminate any obvious malfunctions there. Now, usually failure in these units is caused by mechanical wear and tear of the internal switching mechanisms. And the other thing that can cause problems is contamination on the contacts. And that could be responsible for more of an intermittent issue. But now that I've seen the relays actually working, my mind is starting to wander back to the way the factory actually installed these units in the first place, because there could be a couple of things at play here. Somehow, theoretically, all of this thick white grease could have caused a connection problem. Maybe the sheer quantity could have actually displaced one of the female connectors in the plug. Or maybe because all of this grease is packed in, it might be causing one of the relays to heat up beyond its usual operating temperature. Maybe all of this goop is kind of acting as a thermal insulator, preventing proper heat transfer, slowly increasing resistance inside the coil as it heats up. And that would mean less current available to actually generate that magnetic field needed to keep the switch on the secondary circuit closed. So if that voltage drops, it pings open, disconnects, bike shuts down. Theoretically, it could happen. Or was it just simply that dodgy pin on the relay causing a connection issue? Or did the plug just need a good clean out? It could be one or a combination of any of those things. So with the plug cleaned and inspected, I decided that I was just going to go ahead and replace all 4 of these units. What I got was 5-pin versions from Bosch. Now, these are also micro relays, reference 033-220-1107 to be precise. And the capacity on these units is 12 volts and 30 amps with an operating temperature ranging from -40 to 100 degrees Celsius. So they should be pretty temperature resistant. Now, Bosch say that each of these units is good for around 250,000 actuations, and they're going to cost you about £8 each. Now, considering how important these are on the bike, that's probably a relatively small investment for quite a lot of peace of mind. So for me, it made sense. Now, before installing these, I also wanted to add a little touch of dielectric grease, the idea that this would keep out any water ingress, protecting the connection without creating any additional resistance. Now, at the time, I wasn't 100% sure that changing these relays was going to fix the issue. It could have been something completely different, but I am very happy to report that since I've done this job, I've had zero problems with the bike. I've taken it for a ride for about 50 or 60 miles, no engine cutouts, no issues to report whatsoever. Now, I'm not saying that this has 100% fixed the problem because it is intermittent and it may just spring up in another 100 miles or so down the road. At this point, I just don't know. If that happens, further investigations, it could be other things, and I do have a list of potential candidates that I might look at next. But for now, it seems to have gone away. So in 2 years of owning the bike, one little minor hiccup. So I've got to say that's not too bad. I've definitely owned much more expensive bikes that have had way more problems. And so far, it appears that it's been a relatively simple thing to put right. So I'm back to being happy again. I will, of course, keep you updated if that situation changes. For now, that's it. If this video has been helpful, please don't forget to give it a thumbs up. And until the next one, ride safe.